Aryabhatta was born in the late 5th century in Kusumapura, a region that was part of ancient India under the Gupta Empire. He is believed to have studied at the renowned Nalanda University, an ancient center of learning. His contributions to mathematics and astronomy were monumental during a period when much of the world's scientific developments were still in their infancy. He made pioneering contributions to the field of mathematics, especially in algebra and trigonometry. His work on the approximation of pi is one of his most famous achievements. Aryabhatta calculated the value of pi to be approximately 3.1416, which was remarkably accurate for his time. He is also credited with the invention of the place value system, which is essential for modern mathematics. Aryabhatta used the number 0 in his calculations, a concept which was later adopted universally. He introduced the Aryabhatta algorithm for finding the square roots of numbers. Aryabhatta proposed that the Earth is spherical and rotates on its axis. He was the first to explain the occurrence of eclipses and the concept of the Earth's axial rotation. Aryabhatta's theory of the Earth's rotation challenged the long-held belief in a stationary Earth. He accurately described the period of the sidereal year, the time taken by the Earth to orbit the Sun, which he calculated to be 365.358 days, very close to the modern value of 365.25636 days. He also proposed that the moon and planets shine due to reflected sunlight, and that the apparent motion of the planets is due to their own orbital movement and the motion of Earth. Aryabhatta's most famous work is the Aryabhattiya, a treatise on mathematics and astronomy written in verse form. It is divided into 4 chapters: Gitikapada, on basic principles of astronomy; Ganitapada, on arithmetic and algebra; Kalakriyapada, on timekeeping and astronomical methods; Golapada, on spheres or spherical astronomy. Aryabhatta made significant contributions to timekeeping and the measurement of time intervals. He introduced the concept of sidereal time and calculated the length of the day as 23 hours, 56 minutes, and 4.1 seconds, very close to the modern measurement. He is also credited with the development of trigonometric functions. He defined sine, referred to as jaya, and cosine, referred to as cojia, and formulated several trigonometric identities that laid the groundwork for later developments in the field. Aryabhatta's work had a profound influence on later scientists and mathematicians, both in India and beyond. His Aryabhattiya influenced many scholars in the Islamic Golden Age and was translated into Arabic, where it was used by scholars such as al-Battani and al-Khwarizmi. His work on astronomy inspired later Indian astronomers, including Brahmagupta and Bhaskaratha. Aryabhatta's innovative concepts were incorporated into Indian astronomical models and helped shape the scientific tradition of ancient India. Aryabhatta's scientific theories were ahead of his time, and many of his ideas are still respected today. While the heliocentric model, the Sun as the center of the universe, was popularized much later by Copernicus, Aryabhatta's suggestion that the Earth rotates on its axis indicates an understanding of the heliocentric principle. Aryabhatta correctly explained the causes of solar and lunar eclipses as a result of the shadow of the Earth and the Moon, a view that was ahead of its time. He was one of the first to suggest that the Earth was round and rotated around its axis, refuting the flat Earth model that was prevalent in many other civilizations. Though little is known about Aryabhatta's later years, it is generally believed that he continued his research and passed away around 550 CE. His exact date of death remains uncertain, but his legacy endures through his works, particularly the Aryabhattiya. In conclusion, Aryabhatta is regarded as one of the greatest mathematicians and astronomers in history. His remarkable contributions to mathematics, astronomy, and science laid the foundation for much of modern scientific thought. His work influenced both Eastern and Western scientific traditions, though his name is not always as well known globally as figures like Euclid or Newton. Nonetheless, Aryabhatta's impact on the development of science and mathematics is undeniable, and he is a central figure in the rich history of ancient India.